Okay, so our next example here this is an example uses the dot product here, and this is a concept you've probably encountered in physics. This is the idea of work. And what the heck is work? Well, work is done whenever a force acts on an object and this object undergoes a displacement. So it moves from one position to another under the influence of a force. And the force doesn't actually have to produce this displacement, the force just has to be acting on it while this object is moving. Where does the dot product come in? Well, only the component of the force which acts in the same direction or in the opposite direction to the displacement does any work in the question. So in terms of vectors here, work is the dot product of our force and our displacement, or F dot D. Okay? And doing that dot product picks out the component of the force which is in the same direction as the motion given by D. I should just say here that F is, of course, our force vector, and D is our displacement. All right. And the other formulation, of course, is that we can have the magnitude of the force times the magnitude of the displacement times the cosine of the angle between the force and the displacement. Our force is always measured in newtons. Our displacement should be measured in meters. If we do both of those things, work as units of joules. Okay, which makes it roughly equivalent to an energy. Okay, and again, I should throw in here that theta is the angle between F and D. All right, the standard cosine of the angle between them. All right, so pretty straightforward. Here is a possible example that you might have here. A storage box is dragged up a 3.5 meter long ramp inclined at 24 degrees to the floor by a force of 43 newtons applied at 38 degrees to the floor. How much work is done by the force? So let's just draw a little picture here of what's going on. We've got ourselves a floor. We've got a ramp. The ramp is 3.5 meters long. The ramp is inclined 24 degrees. And I don't know, this can be like the top of the ramp up here. And we've got this box that we're dragging up here. So let's put our box like this. Physics is all about dragging boxes all over the place for some reason, preparing you to work in a warehouse or something like that. How are we getting this thing up? Well, we are applying a force of 43 newtons at an angle of 38 degrees to the floor. So I'll just draw this force here like this, and I'll say that that whole angle there is 38 degrees. And this is my 43 newtons. Okay. And we want the work done. How much work is being done here? Well, we know that work is F dot D, or in this case, because our vectors are given in terms of magnitudes and directions, we know it's directions because we've got all these angles in here, we can use magnitude of F, magnitude of D, times cosine of the angle between them. And this one's fairly straightforward here. What's the magnitude of our force here? It's pulling on our box. Richard? Yeah, it's just our 43. What's the magnitude of the displacement experienced here in this question? How far does this thing move? 3.5 meters, yep. Okay, distance up the ramp, okay. Now, what is the angle between this force and this displacement? Well, the displacement works along the ramp here. So our box is kind of going to move just sort of like this. That would be our sort of our displacement vector. Okay. It's 24 degrees from the floor. We're pulling up. Our force up here is in red. It is at an angle of 38 degrees to the floor. So what is the angle in between those two vectors? Yeah, we just take the difference between them. 38 degrees minus 24 degrees gets me 14 degrees. I stick in 14 degrees over here, punch this into my calculator. 43 times 3.5 times cosine of 14. I get 146.03. And our units are going to be joules because our force was in newtons and our displacement was in meters. Okay? And that's pretty much all you have to do for work questions. Most of the time, it's just sub the stuff into the formula.